Hi, and welcome to Data Structures and Algorithms. I'm Praise, and today we're going to be talking about complexity analysis, or at least we're going to be getting the foundation. We're going to be getting foundational information on what it is and the things and why it's important, the things that build it up. So this is an introduction to data structures and algorithms, but I don't think we've ever actually answered the question, what is an algorithm? And it's really important not only for understanding complexity analysis, but also for computer science and programmers at large. So the easiest way to think about an algorithm and what it is to just think about it as a recipe for solving problems. If you think about a regular recipe, let's say this is a recipe for cake. Well, all the instructions in your recipe are giving you the steps to solve the problem of your lack of cake, right? That's what an algorithm does. It's just giving you step by step, hey, this is how you solve a particular problem. But as we know, some recipes are better than others, right? So you might have two recipes for making sponge cake, but one of them will likely be better than the other. And it's the same exact thing for algorithms. We can have multiple algorithms for solving the same problem, but of course, testing an algorithm is a little different than testing a recipe. Like, I can't just eat an algorithm and tell you which one's best. That doesn't make sense. I can eat the cake and tell you which one's best, but it doesn't work the same way for an algorithm. So instead of taste, there are some measures, some criteria that we can use to determine the quality of an algorithm, that we can use to determine how good is this algorithm. The first one is, well, how correct is this algorithm? Does it work? Does it do what we want it to do? The second one is, how easy is it to maintain? Is the algorithm just really complicated? Is it unnecessarily complicated? And then arguably the most important one is a new term for us. It's called runtime performance. Now, this is the one that we're really going to be focusing on. This is what the big boys use. So an algorithm runs on a computer, and computers, of course, have finite resources, and that makes sense. Computers don't have infinite resources. They don't have infinite memory. They don't have infinite space. So as that algorithm is running on a computer, it's using two resources. It's using processing time and it's using memory. So let's say we have three different algorithms. This is algorithm one, number one. They're all solving the same problem, by the way. We have algorithm number two, and we have algorithm number three. Now, they all have some instructions, right? They all solve the problems in different ways, but they all solve the problems. Now, when I run the algorithm one, I find that it uses a lot of processing time and a lot of memory. Same thing with algorithm one. But then we find out that algorithm two, let's say, has less processing time. It still uses the same amount of memory as the others, but because it uses less processing time, we can say that algorithm three here is of higher quality, that it's better than the other algorithms, that it's better than algorithm one and two, because it uses up fewer resources than the others. So at this point, you might be like, well, cool, Praise. Thanks for drawing that handy dandy picture. But how do I still don't know how I'm supposed to tell you which algorithm uses the least of my resources. Well, as programmers, we have tools called complexity analysis. Are you excited? I am. So complexity analysis allows us to figure out the runtime performance. Remember we mentioned that earlier? And all that's saying, all runtime performance is the efficiency of an algorithm, right? So it's just saying, yo, how efficient am I? And the ways that it measures efficiency is by looking at the processing time and how much memory or space was used. So simply put, complexity analysis allows us to answer the question of which algorithm uses the least resources. And it also allows us to determine how efficient is my current algorithm. Maybe I don't have any other algorithm, but I just want to know, hey, how efficient is this algorithm? So if you've made it this far, thank you for watching. In less than 5 minutes, hopefully less than 5 minutes, I don't actually know how long this video is, but hopefully less than 5 minutes, you have a solid understanding of the foundations for moving forward. This can be a complex topic, and I think the foundations are really important. So congratulations on making it this far. And as always, if you have any questions, please feel free to leave them in the comments, and I will try my best to answer as quickly as possible. Bye.